Well, hi, everybody. I'd like to welcome Professor Jennifer Whyte from University of Sydney, who will be telling us about how, the wider workflow of design and hopefully how modeling fits into, supporting engineering workflows. Welcome, Jennifer.
Thank you, Greg. So I'm going to talk about three topics. So infrastructure systems, data-driven design and visualization. And I also have three affiliations. So I've just moved to the University of Sydney, but I've come from running a research team at Imperial College London. I was running the Centre for Systems Engineering and Innovation at Imperial, and so we had a big team of people there doing a range of work around systems engineering and innovation in infrastructure. I was also leading a grand challenge within the data-centric engineering programme, which is held at the Alan Turing Institute, so the National Institute for Data Science and AI in the UK. And now I'm at the University of Sydney, where I'm heading up the School of Project Management and the John Grill Institute for Project Leadership that's held in the Faculty of Engineering at the University of Sydney. And so really, starting from way back in the kind of 1950s and the sort of early history of the computer industry, that's really the era that the management of projects came out of. And so a lot of the work that I've been doing has been thinking about how do we bring how we understand projects out of this era of technology into the era of technology that we're in today. And I did some work on that with Ray Levitt at Stanford University, looking at the different eras of technologies, the sort of hardware and software and capabilities in use on major projects, and thinking about how we moved from that era of kind of large-scale computing and small visualization screens into an era of pervasive computing. And so a lot of the work I've been doing over the last decade has been in the London infrastructure projects, the London mega projects. And what I'm going to do is just run through some of that practical setting, and then I'll talk a bit about the work that we've been doing at the Alan Turing Institute and the kind of modelling that we've been doing there. So just to rehearse some of the projects that we've been looking at. We've been looking at the major projects, so things like airports, Heathrow Terminal 5, Olympics, the London 2012 Olympics, big rail infrastructure, Crossrail, big water infrastructure, Tideway, and now I have a role advising High Speed 2, which is a big national railway network. And when I was looking at Heathrow Terminal 5, they had this idea of a single model environment, so a kind of precursor to building information modeling, this idea of integrated data set. And really, I was looking at how you took that data set and made it real. So how did you move from the data set? How did you move beyond the computer to large-scale infrastructure? And we were really interested in the processes that they were using, both to model, but then also to get from the digital model to the physical infrastructure. On the Olympics, I was looking at data handover. So in these organizations, they create very large data sets on infrastructure. And then the idea is that those data sets get handed over to owners and operators to use the data sets through the life of the infrastructure. And infrastructure can have a life of decades or even centuries. And so how do you hand data from the design project over into operations and use? And that turns out not to be that easy, because it's a transfer across organizational boundaries. And so there's challenges of verifying the data set, understanding the data that people are accepting from the project, and then being able to use it. And so we were looking at that challenge of data handover in the Olympics. I've done a lot of work with Crossrail, and we did work particularly on managing change in large data sets. So how you keep the requirements, the digital asset information, and the physical assets that you're delivering in sync. And so what's called configuration management or configuration control. And we brought together colleagues from Airbus and CERN and Crossrail to look at this challenge of configuration control in large data sets. And all of them are leaders in their fields. All of them have challenges with the volume of data that they have to manage today. So as you sort of aggregate these very large data sets for big bits of infrastructure, then there becomes questions about how you keep that data up to date. If you make a change in one component, what are the systemic implications of that? And that's really something that my team at Imperial have been studying and been interested in over the last five years. Crossrail was at the time the largest construction project in Europe. It was described as doing open heart surgery on a patient that was still up and running. They were busy, digging in very congested sites through the centre of London. We did a little bit of work with them as they moved into that systems integration phase, taking in this virtual reality environment that you can see in the right-hand corner, and that I really believe in this collaborative visualization of data in these kinds of environments, because you have multiple organizations that have to come together and make decisions. And one challenge is getting that data out of the computer so that people can see it, and that they're not all making decisions based on their individual sort of the views of data on a small phone, but they're able to have that conversation together. And so we created a kind of pop-up cave. So if a cave is a immersive virtual environment, and we created one that could be put up and down within an hour or two, and we took it into the offices in Crossrail, and we put it up, and we gave the engineers workflows so that they could bring their own data into it and look at it and understand it. And so we've done quite a bit of work on this challenge of systems integration and how do you integrate these systems, and that's a challenge that Crossrail has had in writ large over the last few years, because a lot of these projects actually really struggle with that kind of systems integration. So we've been doing work then around this notion of the digital twin, working with Tideway on where these projects have progressively brought data scientists in-house into the project, and so working with their data scientists, looking at the kind of techniques that you can use to understand interdependencies in their data sets. Now I'm doing a little bit of work with high speed too, but I think I won't touch on that in any detail. So we did a bit of thinking about the kind of new delivery models that these digital technologies this digital data is creating across these sorts of projects, and the government initiatives that have been going alongside, and the projects themselves, and how delivery has been really profoundly changed through digital technologies. And so I would say that the real change has been the integration of different parts of a process that used to be kept apart. And so the first generation of solutions, integrated solutions, we would say information was shared across organizations, extranets enabled first-tier suppliers to access design data. There was input from drop-down lists, basic data analytics, searchable by file name. First-tier suppliers accessed up-to-date information and could update systems. But really, that integration has grown over the last 10 years. So we talk about a second generation of digitally supported integrated solutions with real-time monitoring, greater integration and digital enrichment, project-owned data combined with remote sources of reference data, searchable data sets using metadata, suggested inputs and better analytics, updates remotely, and attention to version control. This is really moving towards more digitally integrated solutions. So this desire, and this isn't really fully implemented yet, but this desire for digital information to be shared across the life cycle and to and from end users. And I think that really importantly is a shift in how we're thinking about infrastructure, that user data can really drive the delivery, the conception of projects. Cloud-based systems, attention to security, linked data, access management, patterns can increasingly be analysed to inform decision-making, input from sensors and users fed directly into the integrated software. And so really what we've been seeing is this desire for project deliverables not just to be the physical asset, but the physical asset and the digital data, so this idea of the digital twin. A much greater visibility across the supply chain, and that becomes really important for things like net zero. So to get to net zero pollution, we need much better information about materials in the supply chain and how they're being delivered and where they've come from, their origins, and the kinds of processes that they've been through. And then this relationship with owners and operators and end users. So the user can play a greater role with this integration of data across use, operation, and delivery. And we're no longer starting with a blank sheet of paper when we're starting to think about projects. We're starting to think about projects as interventions into operating systems of systems. And so that has implications for how we model and think about infrastructure. And we've actually been doing a lot of work, and I don't have this on the slide, but we've been doing a lot of work at Imperial to think about how do we bring the modelling of the natural environment and the built infrastructure together, and how do we understand across those disciplines. So in civil engineering, we're very good at modelling within discipline. We're very good at modelling structures and water and different aspects. But how do we integrate models and understand in an engineering sense across different areas to get an understanding of how infrastructure sits within a natural environment? Just quickly then, so we've done some thinking about the kind of new delivery models that are arising in delivery of major projects, and these have implications really for information flow between operation and delivery. And so in model one, where there's a long-term owner operator, then they have much more potential to manage a data set between delivery of new infrastructure and the operation of the ongoing infrastructure. And this organizational question really does matter when you're starting to think about integrating models, because these models are owned by different stakeholders, and they're only sometimes partially shared. And so this question about how you think about data in this complex organizational environment is challenging, and it's sort of important to understand the way that environment impacts the data. So in other projects that we've studied, you have a kind of pop-up client. So you have a delivery client that's associated with the project, but then hands over to a long-term owner and operator. In Crossrail, we had a kind of what we called an integrated pop-up client. So they had the delivery partner and the sort of project delivery and the pre-operations in the same organisation, but they still had then this challenge of handing over to a long-term operator. For the Olympics, the long-term operator didn't really exist when they were about to hand over data. So they were kind of, small startups working out how to put in their phones, and, the Olympics was the Olympic Delivery Authority was wanting to hand over a large data set to them. that was challenging in some ways. In the Crossrail case, they had very established clients, but of course what that meant was that those clients had technology systems that were sort of several generations behind what the project had been using. And so then the question about do you sort of essentially dumb down the data to put it into the client systems, or how do you keep the intelligence in the data to use it long term, becomes a challenge. And so, I mean, when I was brought in to lead the data-driven design under uncertainty theme within data-centric engineering program, we were thinking about what can we do with data in these contexts, and how can we really start to mine and understand that data in new ways and model that data. And so, in the data-driven engineering design under uncertainty theme, we have kind of three sub-themes around infrastructure, around complex systems, and around people-centric design. Our interests are in things like predicting systems interactions and potential failures, model integration, problem structuring and scenario generation, bringing knowledge from operations into project delivery, managing design change, sensitivity analyses, and the role of these techniques in understanding better how to deliver sustainable, infrastructure that fits people's needs. And so we have 4 core projects within this theme. One's around data-driven design assurance, one's around data-driven design of civic infrastructure, one's looking at the digital twin and design change in complex projects, and one's looking at design for retrofit. And then we have a range of associated work. And so just this first project on data-driven design assurance, our technique was to try and use text mining and natural language processing to provide insights into design assurance practices. This is seen as a big challenge in some of these projects. How do you assure the data that you have? And looking at the processes of assuring that the job is done the right way. And we were kind of lucky. We were like lucky and unlucky in this project. So we were lucky at the outset because we had 2 projects, two very large projects that were relatively similar. And so the idea was that we were going to mine and understand what had happened on the first project and inform the second of those projects. We were unlucky because we just got into a huge challenge around data access and how we could access that, access that data. So we did a lot of the preliminary work on this, and then we've not really driven this forward. I think it's an area that's sort of ripe for some research and some analysis. So this was our first area.
Question, just to understand what the context, what can go wrong, and that you're trying to avoid?
So with design assurance, it takes a huge amount of time and effort to assure these large data sets, and there's a real sense in these projects that people are not very they're both not very good at it, and they're not very efficient at it. And so the idea was to generate tools that would support decision making. So they wouldn't take the decision making away from the experts, the engineers, but they might highlight areas of concern that they could look at in more detail. They might flag areas in which things had gone wrong in the past. So where had things fallen through a design assurance process, and might need a bit more attention. Where had they put a lot of attention in, but nothing had ever been changed as a result of that attention. And so there's a sense in which, as these data sets grow, then there need to be more and more people sort of signing off that they're correct, that the data, the information is correct. And what we know from previous research, not research on this project, is that often people just press yes, that they don't actually look at the data. And so how do we put in place processes that are actually kind of checking the data? And so what we were trying to do, just looking at the documentation, so just looking at the text information, not at the design information, not at the drawing information, was just to understand patterns in that design assurance process.
Now, is the challenge here a provenance thing, that the data you collected really came from the place you claimed, or is it more like the recording, the measurement is wrong, you're taking a photo of the wrong thing, the model is missing a key detail, like you just have a mistake?
Yeah. So it's more about the actual engineering than about the provenance of the data. So it's about, is the engineering correct?
Okay, so maybe a good way to capture is, what is the state of validation? Because for any kind of modeling or data, it's, if standard validation is you make a prediction about the world, is it right or not? In machine learning, that's sort of possible because you have images. Here, it seems exceedingly difficult.
Yeah. I mean, one of the challenges of using data science and machine learning in this context is just the heterogeneous nature of the data. Yeah, and so here we were trying to sort of simplify that in a sense in just looking at the text data, but actually, what people are looking at is a lot of model and CAD data,
Right.
that sits alongside that. And so the real challenge is how do we understand that CAD and model data? And there's some work going on things like semantic enrichment to try and get more information into that data. One of the challenges, of course, is that a lot of this data is structured in industry foundation classes, so it's quite an old format. It's been around for kind of 40 years anyway. So kind of it's a relatively it comes out of the STEP formats in manufacturing, and there's some work in my team around linked data. So looking at linked data approaches to combining different data sets in the design data.
Got it. Okay, thank you.
So in this project, we were just looking at the text data, all the documents, and these projects create a lot of documents, the documents that sit alongside that, reports and what have you around the design assurance of these documents, of the engineering data. We've done some work on kind of conceptual design, and so one of my colleagues who's sitting in the transport systems lab and working with us in this program has been doing a lot of mathematical modelling on quantifying uncertainties and looking at optimising transport systems, and both around some of the kind of issues around transportation, multi-mode transport, wireless charging lanes, optimization of demand responsive transit systems, also things around the supply chain. So they've done quite a bit of work on how do you optimize construction supply chains, and then also a bit of work around this post-disaster infrastructure repairing. I know they've been doing some work in COVID, looking at how do you get deliveries in and out of cities in effective ways. And so they're really looking at use data. So they're kind of looking at, how do we mine the usage data that we have on transport systems, to help us think about what next? How do we intervene into these systems? We've been doing some work again on design change in digital twins. So here we've been in this project we've been using some of the computer vision techniques. So identifying changes using scan versus BIM techniques. So comparing BIM models with data captured through scanning, through computer vision techniques. Calculating change propagation using a kind of design structure matrix approach. And then looking to bring that into a kind of collaborative decision-making process to inform design and to make better design decisions. And so this sort of continuous scan versus BIM to identify changes in digital twins and understand change propagation is an area of work that my team's been engaged in. Working with colleagues in computer science around the scan versus BIM piece, and then working on the BIM data and the change propagation with this design structure matrix approach.
So, question on this: how do you create such digital twins from very unstructured descriptions of the world, right?
Yeah, I mean, so I guess in this sector they're maybe not as sophisticated as in some of the manufacturing sectors where they talk about product lifecycle manufacturing, the PLM kind of approach, and the idea of the digital twin in infrastructure has really come out of operating infrastructure. And so in the UK, you might have heard of the desire to have a national digital twin, so to work from the national system sort of down, if you like. My research has tended to work from the project level. And there's some real challenges with scaling up and scaling down across those data sets, and also purpose in some of those different data sets. I think there's real potential in this idea of comparing and contrasting a design model, a BIM model, with this computer vision data. So this data on what's actually there on site as things are being designed and implemented. And so there's a bunch of research and some startups in this space around computer vision on construction sites. So understanding what's as built and comparing what's as built with what's designed, and identifying changes in that data set. So it's keeping that design requirements, the digital data, and what's actually physically there together. I think
it sounds like you have two things here. You have one building, let's say. You have a model of a building that you could have like an architecturally valid model. And then and hopefully it's just a building and nothing more like an entire rail network of a country. It seems like that's where my concern is, when I have no idea how to build something like this to deal with all the details. And the other issue, it sounds like, what is the live state of this model system, right?
Yeah. So I mean, I was sitting on the committee that wrote what's called the Gemini Principles. So it's about the digital twin in the UK. And we had a lot of discussion about whether this was real time or not. And I think the decision was in the Gemini Principles that to sort of relax that real time requirement around the digital twin. So the idea that you've got a model of what your infrastructure looks like. It might not be second by second being updated, but it's sort of updated. It's updated enough for you to be able to make decisions about future changes to that infrastructure. And so, there is a lot of work going on putting sensors into infrastructure so that you can get real-time information back from bits of your assets. And so projects like Crossrail are kind of now full of sensors so that they can be monitored over time. It adds to the complexity of building infrastructure because now you have cyber physical infrastructure, right? But there's a lot of work on that. I personally think there's a lot to do with computer vision. I think computer vision techniques are really, really powerful in this space. Because you can generate the BIM model from the computer vision. So it kind of raises the question, do you need to generate all of the design information, and collate it and hand it over, or does computer vision play a role in that kind of handover of data into operations?
So I think maybe it's coming from the audience here, where for us, obviously vision is a doable problem that I guess Google has had a lot of progress in that. But creating the model of the building itself seems far more difficult, where even if you drag a camera around, you can see some of the pipes. You have no idea what's inside the buildings. And if somebody earlier, had those drawings for it, you have to actually dig it out from hopefully a blueprint. If not, somebody's, asking somebody. It seems to be the norm. So how do you normally set up models like this when normally it's a community that understands the system as opposed to one social truth?
Yeah, I mean, basically, there's kind of two sets of techniques in the research community. There's scan to BIM, where you're trying to build the BIM model directly from the scan. What we've really been engaged in is what's called scan versus BIM, where you have a BIM model and you have a scan, and you're kind of comparing them and looking at the delta. So you've got.
I don't think is that a design term?
No. I mean, you've got some computer vision data, so you've got your kind of laser scan or your kind of or photographic information. I mean, we've been using laser scans in this case. So I mean, the two techniques are called scan to BIM and scan versus BIM. We've been looking at scan versus BIM because we're starting with a design model. So we've got a design model, we've got something that's in the real world that we're scanning, and then we're comparing them. And that's, frankly, an awful lot easier than trying to build a BIM model from scan data because of all of the problems of occlusion and, identifying what things are and, is it a pipe or is it that just becomes a huge challenge. And it's challenging enough that this 3D recognition. So we've been working with Stefan Lutenegger, who's now moved to the Technical University in Munich. And they've got lots of techniques for identifying 3D objects in these kinds of scans. And so we've been doing a bit of work on that. So moving from the as-designed BIM model to the as-built BIM model, to the, I can't remember what the AI BIM model is, but sort of this idea that you've got these BIM models and you're using the scan data to kind of help you update them through that process.
So then maybe one more question on this. When it's a physical artifact, I can sort of see how this goes, especially a fixed one. But if it's something like a rail network or a trade network, things that do not readily show up as boxes or pipes or something like this, what do you do then? Is it oral or is there more support for that?
So I mean, we've been looking at this on the construction site, so on a building site. I did do a little bit of work a few years ago with Bentley, who were scanning rail networks. I haven't used this. We haven't been looking at this on linear infrastructure. I'm sure there are lots of challenges around the linear piece. Yeah, I mean the kind of visualization techniques that I've seen used on visualization on rail infrastructure have been things like the kind of remote expert piece. I haven't seen this being used. It's not to say it couldn't be used, but I think at the moment our research has been focused on the sort of local problem of a building construction site and tracking the materials and the work that's going on there. And so this is the kind of work that people in the team have been doing around understanding the BIM model, the sort of semantic enrichment of the BIM model, to try and understand some of the interdependencies in that, understanding the change propagation through those models. I've got a team that are doing work on what's called an AEC production control room. So they're working with Mace and others in the UK to try and make this data then available at the construction site. And so this is the kind of large screen data display to show different aspects of the data that's available around construction and progress on construction. So bringing together some of the scheduling data and some of the modelling, the BIM. When I'm saying modelling here, I'm meaning the BIM data, the design data, but really to understand and to understand that in a better way. And for me, this kind of big screen display is really important for the kinds of collective decisions that need to be made in this industry. So this is the work that Ranjit Soman and Karim Ferali are doing. And both of them, by the way, spoke at a symposium that we put together for Chuck Eastman. So Chuck Eastman is kind of seen as the grandfather of BIM. He was at Georgia Tech. And so that there is more information available through videos online, and I can point you to those if you want them. This again is Ranjit's work looking at linked data-based constraint modelling and checking for AI-assisted look-ahead planning. So look-ahead planning is the kind of it's between the large-scale scheduling and the kind of day-to-day work on the construction site. It's a kind of 6-week look-ahead process, and he was looking at how do you bring different types of information together. How do you link different data sets to make good decisions at this stage, and look at the constraints that are to model the constraints that are operating in this process. And so he's been doing this work on linked data-based constraint checking to support look-ahead planning and construction. I mean, the other project in the data-driven design under uncertainty grand challenge is around retrofit, and retrofit is just a massive and growing challenge in the built environment sector. In that if we're going to meet net zero, then we're going to have to upgrade a lot of buildings, and so this work has been reviewing data-centric retrofit methods. It's been doing some work on uncertainty in building energy modelling. It's been trying to develop and maintain an open access database around this, and then use sort of structured decision-making tools to manage the uncertainties. And yeah, I mean, we've started to publish out of this as we've started to publish out of all of this work. This is really kind of where I wanted to end the discussion, and I think we've got loads of time to discuss a little bit. But I think you know, we've done quite a bit of work over the years on visualizing these data sets. So I've written a second edition of the book on virtual reality and the built environment. The picture on the sort of bottom left-hand corner is the mission room that I was just talking about, that's bringing some of this data out into the construction site. The other images of the pop-up cave that we took into Crossrail, and you know, before we built that pop-up cave and took it into Crossrail, we had lots and lots of the design and construction teams come to our university and look at their projects in our VR facilities. And yeah, what was amazing was that even the people who'd created the models really saw new things in these big screen displays and these big screen visualizations. And so both for the physical models and then also for various forms of modeling data and analyses, I think these big screen displays are really important in this kind of environment, because they allow a group of people to come around and see the same data. You know, one of the challenges in this sort of sector is that people are often looking at different sets of data, you know, understanding different things, and so you know we've done some work on this kind of collaborative visualization approach. That's really, I think, the end of my presentation, and I you know, kind of would open to any questions or thoughts from the floor, and I wonder how it chimes with areas that you're progressing, you know, and this question about approaches to model integration in areas such as infrastructure, you know, and any areas in which there may be mutual interest and areas to collaborate. So it's really kind of the end of what I was going to say today.
Well, thank you very much. It was fantastic. Before I ask my questions in the queue, does anybody else have questions?
Yeah, hi, my name is Marco. I used to work quite a bit in the area of building and energy modeling, and I've seen my share of people trying to convert BIM models and IFC models to Modelica models and Energy Plus models. I wonder if you've done any work on basically using like BIM models and data to basically operationalize buildings and making sure that they operate as intended.
I was just in a conversation about that last night. So I think that post-occupancy evaluation piece is really kind of important in this space, right? And I think there's sort of some opportunity to do more on that. You know, because I think the problem that you're alluding to, if I'm understanding you right, is that there's a lot of modelling of what the energy use of buildings will be, you know, kind of ex ante, and then of course it turns out that the way that people use the building means that they use a lot more energy than they were designed to use, and so, you know, I think user behaviour certainly has a role in that. You know, I think it was kind of interesting. One of the big landlords in the city in London started to display how different occupants of floors in a building were using their energy, and you know, of course, it meant that the energy came down because people were seeing it as they were going into the office, and there was a kind of competitiveness between the different companies that were in different floors of the building. And so, you know, kind of, I think that question about how do we use data about use of infrastructure better to inform design, I think that's a really important area, because there's just so much data now about how infrastructure is being used, patterns of use.
Thanks.
So I have a question about uncertainty. So how does uncertainty about the building, or it might be earthquakes or wind or the supply chain would be, you know, Suez Canal getting blocked. So how does uncertainty propagate through visualization and project analysis?
Yeah, I mean, it's a good question. I don't fully have an answer to that. We're doing a little bit of work in the team that are working on the data-centric engineering program at the moment on uncertainty. Yeah, and I think if you look at the kind of modelling, the stochastic programming that say Leo is doing on the transport, you know, he's dealing with kind of aleatory and epistemic uncertainty. Yeah, but the challenge is these kinds of radical uncertainty, right? And you know, can we quantify more of them? You know, how do we deal with the kinds of uncertainty that at the moment are not well represented in the models? You know, for me, that's partly why this collaborative visualization of data becomes really important, because you know, you're modeling what you can model, but you're having conversations about the limits of the model, and you're kind of you know, kind of discussing whether the assumptions in the model are you know, are critical, right? Because you know, one of the challenges in those you know, in dealing with some of those uncertainties that you have around infrastructure, you know, is you know, are your models modelling the right things? There is some work going on this kind of long-term uncertainty in infrastructure. So there's been colleagues in Imperial doing work on how do we model long-term climate uncertainties in infrastructure and things like that. But I mean, I think, you know, we've been very interested in integrating models, and we've been very interested in then visualizing that data so that decision makers can see, you know, ideally both the model but also the assumptions and the kind of the uncertainties in the model. And you know, that bit is more difficult to show. So one of the problems with the kind of BIM models is that they look very certain, right? And so how do you visualize some of those uncertainties in the data set, I think is a kind of real challenge. We haven't cracked it, but it's something that we're very interested in.
So then what's the state of the art? I'm thinking there's two scenarios here. One might be that there's some parameters of the world, and just think like wind for a building. It's not like a crazy thing, just how sensitive is the building to this stimulus, as well as 10 others. So this combinatorial explosion and the uncertainty in what normal is, or I guess saying this building is this reliable and some quantification. Maybe let's do to this one. How do you visualize the stochastic environment? Not crazy like edge case, just normal stochastic environment of a design.
Yeah, I mean, not very well, I think, is the answer at the moment. So, I mean, what you could see in the AEC production control room is, you know, just a whole load of different kind of visualizations of different pieces. You know, there is a little bit of work around, you know, making things more or less transparent in BIM models to sort of show the level of certainty around different pieces of the design. You know, it's an area that I think it could do with more experimental work to sort of see what people are understanding. You know, are they understanding the uncertainties in the models they're being shown? And you know, my impression is not always. You know, and it's a kind of it's a challenge when you're making decisions that have social consequences, and so you need to get input from a range of stakeholders, some of whom will be much more sophisticated at understanding the data set and understanding the modelling than others. You know, and it's one of the challenges that we've had, bringing really sophisticated models into this sort of environment. So, you know, one of the pushbacks, if you like, that we get from industry partners is, you know, it's all very well doing all this clever modelling, but, you know, how do we then describe the outputs in a way that people can understand, you know, they can kind of trace from the inputs to understand how the decisions have sort of been made through that model.
So this is just a validation of the model here.
Yeah. So that kind of traceability of kind of, you know, it's something that I think we're not very good at yet in construction. You know, I think the medical industry, for example, is better at explaining some of that statistical data and you know, kind of probabilities and kind of uncertainties in their data sets than we are in construction.
Okay, so is there a notion of, I guess, validation in the sense of the model says this should happen, this did not happen, the model is this % wrong? Is there a possibility of this? Are there predictions that can be derived from such models?
We tend to talk. I mean, we tend to talk really about information completeness rather than about modelling accuracy. Although we should really be talking about that as well. So I mean, yes, to some extent, yes. I mean, one of the big challenges is that different bits of models are being produced by different companies and then being integrated. Yeah, and so the problem that you have in any kind of mathematical modelling is just the quality of the data, the inconsistencies in quality of data across those data sets, which is why there's quite a lot of work on things like semantic enrichment. You know, kind of how can we ensure that we've got quality of, you know, how can we you know, identify where data is missing in these models and kind of add it, basically.
So now I'm getting the impression that the focus here is on systems where the dynamics are pretty simple or well understood, and it's the accounting for which bits are there and how they're connected. That's the challenge. Is that valid?
Yeah, I mean, I guess in my world it is. Yeah, you know, it was interesting when we did work on with Tideway, because we brought 3 universities together to look at the digital twin in Tideway. And what you discover immediately is, of course, people mean different things by the word model. And so our colleagues in Sheffield were doing a lot of work with time series data. Now, you don't have a lot of design series data actually in the construction process. Mm-hmm. You get that data, you know, in operations, you get that kind of data about, you know, kind of water flow or what have you in an operating infrastructure. You're just missing that data when you're designing it. You have some predictive data that the designers have created, but you don't really have anything to test it against. And then we had colleagues in Newcastle who were doing work on kind of formal modelling of systems. So they had a kind of co-modelling approach to try to look at how you could create models out of data sets that weren't fully integrated. So you could take information out of those and create understanding. Those different forms of modelling, you know, have different uses in design and operation of infrastructure. And so what we essentially did in the end of that project was sort of map out where some of those different techniques were useful, because that's one of the challenges that people sitting in these projects have is, you know, there's a ton of modelling approaches out there. Where do I use them in different parts of my large project?
So then maybe this is a good question here. It's what are the questions that need to be answered by such models? Like by the stakeholders? What do they need to know?
I mean, I think increasingly those questions are about sustainability of the infrastructure. So you know, from the outset, from the conception of the infrastructure through, I tend to be looking at the delivery phase, but I think there's a ton of interesting questions at conception of what do we do, how do we intervene into infrastructure. You know, and that's where we've been doing the modelling around the transport systems, for example. So, you know, how do you decide what intervention to make, and then, you know, what's the resource envelope for delivering that intervention? So, you know, kind of how do you decide on the budget and the timescale for delivering an intervention into operating infrastructure, and so there's a ton of questions about how do you choose an infrastructure project, how do you choose to intervene into a city, you know, whether it's new buildings or new roads or new railways or new cycleways, or, you know, what's your intervention? So there's a ton of questions around that. In delivery, I think the questions around design are really questions about you know, kind of the best solution. So you know, some generative design is used in design processes to try to understand what a good solution would look like. In delivery, then it becomes a lot about the schedule. And that's why, you know, in our work, we've been doing work on things like this sort of 6-week look-ahead planning, because time is money on a construction site, right? And so the question about how do you deliver, you know, effectively, how do you deliver fast, you know, becomes kind of pressing for people on the construction site. And so, you know, I guess the questions that different people are asking kind of change over time. There's a really interesting phase in the project where data is then handed over to operators, because you have people who have quite different, you know, kind of goals, if you like, coming into contact. So, you know, the people in the project just try and get finished and get out of there, get to the next project. Whereas the people who are going to operate that infrastructure, you know, if they're up and running enough to notice, then that, you know, they have some uses for that data, you know, through life, to be able to operate the asset, to be able to understand what it was. In the Olympics, it was kind of interesting because they immediately had a kind of retrofit project, right? So they had games. So, you know, they had a hard end date to the construction project. They had the most numbers of heads of state around the world come to an opening of an Olympic Games, and so they had a big start to that project. And then immediately after games, they started reconfiguring all of the venues for legacy use. And so they immediately needed the data to reconfigure the venues. And one of the big problems actually is delays in data being passed between organisations. And so, you know, getting that data to know what they needed to do in the retrofit was kind of one of the challenges. And, you know, it's partly why I think computer vision becomes one of these kind of areas that's kind of interesting to people, that you can get quite a lot of data just from the physical systems that you've got in place, without having necessarily all of the design data and the modelling. You know, and you know, in the PLM systems that they have in the aerospace industry, you know, they have a lot of that modelling data captured in their PLM, so you can go back and understand the logic as to why those decisions were made. Mm-hmm. And, you know, we need a bit more of that in infrastructure, so that when people are changing buildings, then they understand the logic as to why things were done the way they were done, you know, and if they're changing something that's structural, for example, or if they're, you know, kind of, you know, that they know that they're doing that, and that you know, that is a challenge, that people don't always understand the building when they're changing it. So, you know, there's a ton of kind of there's a ton of challenges of data. There's some challenges of modelling, but there's also some challenges of just having the data sets that we can really mine and understand patterns in. You know, and I think these projects are generating really large data sets. There's some real opportunities to use some machine learning to understand patterns in those data sets. Yeah, but there's also some challenges. Yeah.
What are examples of patterns? I mean, I can imagine big transportation. I can imagine modeling people's use of the transportation system. How many people get on the tram to go from place A to place B? That's sort of easy because it's a known big problem. but it's sounding like you also have to infer the dynamics of the system you are building because you do not perfectly understand its operation. Is that right?
Yeah, I mean, there's a lot of modelling done around things like supply chain dynamics and kind of getting things to the site, getting them put up on site, especially as we're moving towards more off-site production. So, if you think about the crane on the construction site is your last machine in the factory, really. So you've got a slightly different task than if you're producing cars and you're putting them in the car park outside. You've got all the. I mean, we've done quite a bit of work at Imperial on the logistics between the factory producing off-site components and the construction site. Yeah, especially in urban areas where you don't have real lay-down areas, so you don't have that kind of buffer of just being able to put things down and then put them on site. The understanding, how to flow things through that supply chain is one area that's a lot of modelling work on.
So one question. So normally, a lot of these design projects are increasingly automated. So there's always this problem of what are people going to be doing if a lot of the jobs are taken by machines, especially the middle skill people. So some theories of this is if design and construction are more unique, and maybe robot assisted but human led, then that works out. I mean, then there's a real value that humans can add. It seems like the design and deployment process becomes vastly more complicated if every deployment of every new residential home or every new whatever this little subsystem is now fairly unique, right? It's not a mass produced kind of scenario. How much more difficult it becomes when you have low scale people doing unique-ish kinds of designs.
Yeah, I mean, I think there's a sort of mass customization approach, right, where things that are very standard, you just standardize, but things that kind of are you can add some value, then you look for more unique solutions. But I really believe in that off-site approach to construction because mental health on construction sites is not good. And safety is a challenge on construction sites. So we want to take people out of those difficult, dangerous environments and put them into environments where their working lives are better.
Right.
I think there's a sort of moral obligation to the people in the industry as much as also the quality can be better, right? So you've got more control over quality. You've got more information about what you're producing. If you want to tackle some of these big challenges around net zero, for example, you need that information. You can't operate on a muddy construction site where half the materials are wasted because people don't know where to put them, right? So sort of optimizing some of those processes becomes really important.
Well, cool. Thank you.